You use it every day. It's on your Face Unlock, it's on your Netflix, Amazon, and every other application that you use. You must get a pretty understanding as to what you're talking about right now. Yes, you're speaking about machine learning. So behind all of these different Netflix recommendations and every other apps that you use is a very simple yet a complicated topic called machine learning. So welcome to video number 2. In the last video, we deep dived into what artificial intelligence is. If you have not checked that video, I'll link down in the description below. Please do check it out. If you do not know me yet, I'm RC and I'm a data scientist. I've been a data scientist for over, 6 years now. And one thing about me is that I'm from a purely non-technical background. I did my bachelor's in biotechnology and master's in biostatistics and epidemiology. I know it sounds all biology and sciencey, but how did I get into AI? That's a story for another day. But somewhere in between, I got into AI, and we're talking about pre-ChatGPT era here, so I'm not vibe coding here, as you see. Anyways, when I just started out, it's been very difficult for me, and I remember some days where I couldn't get hold of certain SQL queries, and I even cried a couple of days. All right, coming back to the video. So here I am. I want to help you get started in this AI journey, and let's do it together. I want to make you a tech genius, and you need to go back out there at work, at your home, or if you do not have any topic to talk to your friend about, talk about machine learning. So from cooking a biryani and then simultaneously learning about machine learning, let's get into today's video, shall we? All right, let's begin with what exactly is machine learning. Even if you're from a non-technical background, I believe that at some point in your life, you must have at least used a print hello world statement in any language out there, C, C++, Java, Python, whatever. So what happens when you print hello world? This is a simple program that you instruct your computer with. And the computer understands the statement in whichever language you write it. And it prints the sentence hello world, right? So this is traditional programming. You give the computer a specific rules or in terms of a program, and then the computer executes it for you to get you the desired output that you want. So this has been traditional programming since before machine learning was a thing, which is, trust me, back in 1950s. Anyways, so what machine learning does is, instead of giving a set of instructions directly to the computer, you give it the data and then the desired output that you want. So what happens in machine learning is that you give your computer the data and then you give what kind of an output you want. So unlike traditional programming where you give the set of rules, in machine learning, the computer frames the rules itself. So to put it simply, that's the whole machine learning for you. But let's get into how it actually works. What happens behind the scenes in a very simple way. Do not worry. I'm not going to get into any technical jargons just yet. Okay. It involves a 3-step process. So we have the first step called data collection. So this is the step where you collect all of the data that you want to input your computer or model with. So we are talking about if you want your computer to identify which is a cat and which is a dog. So you collect thousands of cat pictures and dog pictures, and then you feed this picture into your computer. So this is your whole data collection process. The other types of data that you would collect is basically not just pictures. So let's say you want to build a recommendation model, or similar to how Netflix works. So you gather information about a specific user who regularly uses Netflix, what kind of movies they watch, what kind of series they watch, how long they watch it, at what time do they watch it. So all these information you collect, and then you give it, you give the model with all of this information. So the next step number 2, is where you train the model. So by training, you are not going to be, training your model like how you train your dog, but essentially, as an analogy, that's actually right. So how do you train your model? You kind of whatever data that you've just collected, you feed that into the model, and then you instead of just dumping the images that you've just collected into the model, you label it. So all of these cat images will be labeled as cat, and all of these dog images will be labeled as dog. So now the model has a training data from which it can understand and gather patterns. For instance, from the cat images, the model would understand what a cat would look like. So a cat will have pointy ears, comparatively a small body, whereas a dog would have a very, you know, comparatively bigger ear and a bigger body and a tail and whatnot. So the model understands all of these patterns. So this is what happens in your training step. And the last and final step is your prediction. So from all of these data that you've given the model and all of the patterns that it has understood, now the model has all the information that it needs. It sets itself a set of rules from based on these patterns and gives you the actual output. So let's say you give a new cat picture or a new dog picture, which is not initially in your training data. And now the model is capable of identifying which is a cat and which is a dog. Of course, you can feed it with a camel picture or an elephant picture. Initially, if you do not set any guardrails or if you do not set any specific instructions as to predict only a cat and only a dog picture, it will eventually kind of categorize the other images as not a cat or not a dog. So very simple, right? Just a 3-step process: data collection, training, and then prediction. So this is on a very high level as to how machine learning works. Now, there are certain 6 key ingredients that you need to understand in order to understand machine learning well. In order to make it simpler, let's compare machine learning with your average biryani. Could be any biryani, chicken, mutton, if you're a vegetarian, veg biryani, whatever. So just imagine machine learning and imagine biryani so that it stays in your heart forever. Anyways, so the first ingredient is data. As we already talked about, data is a very key ingredient as compared to a rice or a meat of the biryani. So proper rice and proper meat would give you the best biryani, right? The proper composition for 50 grams of rice, it needs to be 50 grams of meat and so on. So bad biryani is a result of bad rice and bad meat. And similarly, a bad model is a result of bad data. Now, we have this, right? The first ingredient is data. The second ingredient is your features. So we have the rice and we have the meat. What does a biryani is composed of? Without which biryani doesn't make any sense. It's the spices, right? So your cardamom, saffron, turmeric, your clove, bay leaves, whatever spices you add to your biryani. So all of these spices are the key attributes of your biryani. So similarly, all of these features are the key attribute that is needed by the model. So for instance, if you're feeding your model with a specific image, the pixel, the color, the temperature, all of this is what we call it as a feature. If you're looking at a very structured format of a data, or table, for instance, so similar to an edge-less recommendation algorithm, the columns where you have the user information, such as what genre they are interested in, what time of day do they use Netflix more, and how often they see a movie. So all of these different things are features that you're collecting in order to give it to your model to train it, right? Now, the third key ingredient is the model itself. So you have the spices for your biryani and you have the rice and the mutton with you. But what do you do with it? How do you mix it? Or what proportion of different spices do you add? So that, in exact sense, is your model. It's the mathematical representation of all of your data and features so that it can be understood by the computer in the best possible way to give you the best possible output there is. So now I've spoken about data, aka rice, features, aka spices, and model, aka the whole recipe of it. The fourth key ingredient we have here is the algorithm. So you have all of these ingredients with you and you have the recipe as well. But how do you cook it? do you measure everything and put it into a pan, or do you just put it in a cooker, or do you slow cook it, or do you use a dum to cook your biryani, or do you use an instant pot? There are so many ways out there, right? So just with that, algorithms are the set of instructions or the technique in which the model has to be trained. There are techniques like gradient boosting, random forests, decision trees, neural networks, and so much more. We will look at each one of them in the upcoming videos. But just know that there are a lot of algorithms out there, and this algorithm is what ensures how a model learns, right? So let's get into our fifth key ingredient, loss function. So in order to put it in biryani aspect, so you have mixed all of your raw materials, and then you've even cooked it. Let's say you cooked a dum biryani. Now you're opening the lid of the dum, and then the aroma of it spreads across your room, and everybody at your place gathers around. And what do they gather around for? You guessed it right. It's for doing a taste test. So when you do a taste test on a biryani, what do you find? So you look for deviations from the expected outcome, right? So this is a loss function. Let's assume that. So the line in between, the median line or the slope, is your expected outcome as to the best biryani out there. So this best outcome is the most 100% accurate thing. Now you want a biryani to be this, but instead, if there is less salt, or if the meat is undercooked, or if you want your rice to cook even more, so this deviation from the actual is the loss function out there. So in terms of model, so for every wrong cat picture it predicts, or every wrong dog picture it predicts, that is the deviation from the expected outcome. So this deviation, we measure it with a terminology called loss function. Simple, right? Now we've entered the final sixth ingredient out there, which is, drum roll please. Now you've done the taste test, you've identified that there is, the salt is low or the meat needs to be cooked longer. What do? You fix it. You optimize the biryani. That's exactly our sixth ingredient. It's the optimization process. So just like you would leave the dum on for a few more minutes or add a little more salt to adjust the salt value, these adjustment using different parameters, like there is a specific technique called grid search CV, where the model itself searches for the parameters within the model to understand and improvise it so that it meets the expected value, reducing the loss function. So it's as simple as that. There are different types of training. There are different ways of, how you can make use of your machine learning and then come up with different applications. And also various optimization techniques, which would be too long for the video. And hoping that I've not lost you and you stayed toward the end of the video, thank you very much. I'll end the video right here because today we learned about what is machine learning, what are the 3-step process that is machine learning, and then the 6 key ingredients out there which you need to understand in order to get into machine learning. In the next video, I'll teach you about what are the different types of learning out there. You must have heard about supervised, unsupervised, reinforcement. We'll deep dive into it. And I'll also give you a couple of examples that you can implement right there. Just download the notebook and then upload it onto Google Colab. And bam, you have the first machine learning model up and running. So stay tuned for the next video. And until then,